Hello, Algebra students, and welcome to learning how to make graphs on our TI-84 Plus today. Okay, so if you have me for math, you're going to want to turn to the page in the notepad that says the shapes of algebra, and you want to get your graphing calculator out. You may want to take a moment to pause the video and write in what I have already written, how to clear your calculator, and then the different examples that we are going to use. Okay, so once you're done pausing and writing that down, then we'll start. So first thing we want to do is we want to turn our graphing calculator on. If there's anything on it currently, press the clear button right here, and we are going to clear out all of our RAM just to make sure we're all on the same page. So what we're going to do is, and you want to write this down, to clear out your RAM, you want to press second and then the plus key, and then you'll get this menu. We want number 7, reset. And then it says all RAM or defaults, we want 1, all RAM. And then reset RAM 2, we want to reset it. Okay, and then it should say RAM cleared and we're ready to go. Now, to get that off your screen, you can press clear. You can also always press second quit. Okay, so today we are going to start using our graphing calculator to graph. So the first thing we're going to look at is a linear graph. The general notation for a linear graph is y equal mx plus b. We're pretty familiar with that. And the graph we're going to use as an example is y equal 2x plus 3. So here's what you press to do this. You start by pressing y equals right here in the upper left. And you'll get a menu of y1, y2, y3, y4, y5. And if you keep going, there's more. That's how many different graphs you could put in at one time. But we're going to only put one. So it already says y1 equals. So what we do is we just type in the equation we want. We want 2x plus 3. So we're going to press 2. The x key we use is right here next to the alpha key. It says xt theta n. So that will put our x on. And then we do plus and then 3, and that's entered in. And then what we want to do to see the graph, we're going to press graph. And then it will automatically, since we cleared the RAM, come up with a 10 by 10 graph. And this is what the graph looks like. Okay, so what we want to do in the next part here is, well, first of all, we want to tell what it graphs for us. So this graphs a straight line. Linear graphs a nice straight line. Okay, I know it looks like it's not straight. This is because these calculators are pixelated, but that is the best we have for a straight line. And then it looks like it appears as though it crosses our x-axis at about -1 or a little after. So we want to make sure that we're accurate there, that it's crossing there. And then it looks like it crosses our y-axis as about 1, 2, 3, or 3.5. So we want to make sure that's accurate there as well, as best we can. If you have a ruler, go ahead and use it. I don't at this point, so I'm going to freehand this. And this is what this graph looks like. Now, a linear graph can go any direction. This one just so happens to go from left to right up. It can travel down as well. The other thing that we want to make sure we get when we're doing this is a table. You'll be asked to do tables quite often. So we're going to put this under here. So just say X and Y. And we're going to create a little table from -2 to 2 for X values. So -2, -1, 0, 1, and 2, like that. And then we're going to use our calculator to give us the table. So we could put them in, right? We could do 2 times -2 plus 3, 2 times -1 plus 3, 2 times 0 plus 3. And we can do them out the long way. Well, these calculators will do them for you once you have it entered. Notice there are all these blue words above the buttons, and the one we're looking for here is the blue word table, and the blue words match with the blue second key. So what you do to get the table is press second, and then the graph key, and it will come up with the table. The table will be up and down. So this is saying that when x is 0, y is 2. Or, I'm sorry, y is 3. I can't read that. So y is 3. When x is 1, y is 5. So we have that one. When x is 2, y is 7. But it doesn't show any negatives. Well, let me tell you, these arrow keys, if you keep going with it, it will go as far as you want to, negative or positive. So when x is -1, y is 1. And when x is -2, y is -1. And that is the table for this graph. Okay, cool. So far so good. Everybody hanging in there? Let's do the next. So let's go back. We're going to graph our next one. So let me push this up. The next one we're going to graph is called a quadratic graph. Quadratic graphs are, they're going to be quadratic because the highest exponent on it is going to be a 2 here, right? And the parent function for this looks like this: y equals x to the second power. That's the general function. The example we're going to use is y equals 2x to the second power. So to get back to where we need to be, all you have to do is press y equals. And you could keep that in there, but just so that we don't get confused, we are going to clear that first one out. So press clear, and we're going to enter this new one. 2x, remember, is next to the alpha key. And then the squared, there's two ways you can do this. You can either use what we're used to and use the caret key right here and then the 2. Or on these calculators, there's a special button right on it that has a squared on there. So you can just use that as well. Either one will work. And then we are going to press what button to get the graph again? Oh, yep, graph right here in the upper right. And let's take a look. And what we should get is this nice U shape. This is called a parabola, okay? And so we're going to write that in. Quadratic is a U-shaped graph. Now, the one we got here, since it's positive, the coefficient on the x squared is positive, this is opening upward. They can open downward if that coefficient is negative, and it's still a quadratic graph. All right, so let's go ahead. It looks like this is hitting our x-axis at 0, 0. So you want to make sure you're accurate here on your graph, and it looks like this. All right, and this is just for our nodes, so we're not being entirely accurate. Normally, you want to make sure you label all these little tick marks and label where it's hitting. Okay, so again, we want to make sure that we can get the table on this, so let's go ahead and make one first, x and y, and we're just going to stay consistent with these tables and go -2 all the way to +2 for x values. So that we can compare them and see what it looks like. Okay, so how do we get to table again? What do? We press second and then graph. See how it says table above there? And here's our table. Now mine, it will leave off where you left off before. So I don't need x -5 for this. I started at -2. So at x equal -2, y is 8. At x equal -1, y is 2. At x equals 0, y is 0. At x equal 1, y is 2. And at x equal 2, y is 8. And so you'll notice that the table on here is like mirrored on both sides, right? At 0, 0, which is where it hits the graph, it's its lowest point, it's the minimum, and then it makes sense that it's the same on either side going up, right? It's at 2, and then it's at 8, and then it will continue that way all the way through, and that is significant for a quadratic graph. Okay, let's do the next one. So the next one we're going to do is a cubic graph. Okay, and our parent function is y equals x to the third power. The one we're going to use is y equals 2x to the third power. So press y equals, clear out what we have there. And this is how we enter this one. 2, again, our x key next to the alpha. And then to the third power, there's not a fancy button for that. You're going to have to use the caret key, which is under the clear, and then the 3 for the exponent. And then you have it entered. Okay, go ahead and press graph. And our cubic graph looks like this. It's kind of like, one half of a parabola going one way and one half going the other. But it does not ever stop. This is connected. So it goes through 0, 0, it looks like. And so we're going to draw this in. Oop, I'm going to use a different color here. So we're going to draw this in, looking like this. And this is our cubic graph. And they can actually travel, if they're negative, the coefficient, it'll travel the other way like this, but this is one for our example. So our cubic graph, there's not really a name for how this looks, but you could look at your notes and come up with that. Some people say it's like an S shape. All right, let's find the table, XY table here again. And again, same X values so that we can have a basis of comparison here. So we're going -2 to +2. And let's look at that table. Press second and then graph. All right, here we go. So -2, I'm going to move this so that -2 is the first one I get. So when x is -2, y is -16. When x is -1, y is -2. When x is 0, y is 0. When x is 1, y is 2. And when x is +2, y is +16. Now, this is similar to this. The difference is, right, it is a mirror, except for the left side of our mirror is negative and the right side is positive, right? And that makes sense. The left side's negative, the right side's positive. If it were a negative coefficient, it would be the opposite. The left side would be positive and the right side would be negative. Okay, cool. Moving right along. Let's try exponential now. Exponential is different from quadratic and cubic. So quadratic and cubic both have exponents. Quadratic is a 2, cubic is a 3. Exponential, the exponent is the x. Okay, so that's the difference. So you can have any base number coefficient here. We're going to use a 2 for our example, but exponential has x in the exponent, and so that's important. Let's go ahead and put that in our graph. So go ahead, press y equals, clear that out, and we're going to enter 2. Now we're going to press our caret key, and then our exponent is x, which is the one right next to the alpha key. And then we are going to go ahead and press graph again. Okay, so this, it appears as if it just comes out of nowhere on the x-axis, but I will tell you a little secret. If you zoom this in, this never, ever actually touches the x-axis. It gets microscopically close, but it never touches it. This is called an asymptote. And so an asymptote is when a graph approaches an axis or a line, but it never touches it. So what we're going to draw here for this exponential one is so that it looks like this, right? So you don't actually want it to touch. You want it to be close, and then moving on up, it's going up quicker and quicker, and then draw an arrow just indicating that this keeps going, but it never actually touches there. Okay, and so again, we're going to look at our table. So go ahead and draw your XY down here. And we are going to go same numbers for x values. And the y values might be similar, might be different, but you can tell from the graph that they're going to be at least a little bit different. Okay, press second table graph here. All right, -2. We're at a decimal at -2 over here. It's only, the y value is only 0.25, which is only 1/4. So 0.25. At -1, it makes it up to 0.5. At 0, it actually hits at 1 here. So this spot right here is 0, 1. And then at 1, we're up to 1, 2. And then at 2, we're up to 2, 4. And it goes up. And if you keep going on this one, notice that it starts doubling every time. Exponential gets large really quickly as you get going. So like by the 7th x value, you are already at 128. If you keep going, you're in the thousands by the time you're at the 10th value. Okay, so exponential moves up very quickly or down very quickly. So in this case, we have a positive base number, but if we had a fractional or decimal base number, that's going to go down very quickly, but we will explore that more in depth later. Okay, today is just about getting to know how to use these graphing calculators. All right, next one then, last one. There's not really a term for this graph, but some people call it the butterfly graph. It is when you have a fraction in your equation, and that fraction, the important part is the x is in the denominator of the fraction. If the x is in the denominator is when we come up with a graph that looks like this. So let's go ahead, go back to your y equals, clear out what you've got. Now, to do a fraction in here, there is not a fraction button. You would simply press 2 divided by x when you put that in. Okay, go ahead and press graph and see what happens now. Yeah, you are not seeing things. This is why it's called a butterfly graph. I guess if you turn it to the side, it kind of looks like a butterfly. But you have lots of asymptotes here. You have an asymptote on the y-axis and on the x-axis. So it looks like they hit. They don't. They don't ever hit. So this is what this looks like. If they do go the opposite way as well, if you get negatives. But here's what we want to draw. It looks like it goes like this, and then it kind of comes around and goes like this, but it never actually touches. Same thing here. This one does the same thing, never touching. And this is what the graph will look like when that x is on the bottom, the denominator of the fraction. Okay, let's go ahead with our table as well. All right, -2, -1, 0, 1, and 2. Okay, so let's go second table here. And, oh, I forgot I left off there. All right, at -2, our y value is -1. At -1, our y value is -2, and you are not seeing things. At 0, our y value is error. There is a reason for that. I'm going to put an E here because I can't fit it. If you think about this, right, what happens when we divide by 0? We do get an error. That's no solution. We can't divide by 0. So that's why, because that's in the denominator, you do get an error. And on here, notice your graph never touches 0. It goes whoop, and then it shies away. All right, at +1 for x, we get 2 as our value. And then at +2 for x, we get 1. And so this one is very similar to our cubic graph, where we have like a mirror image here. The difference is we have an error at the 0 here, and here we have a 0. So there's our difference, right? This one has in the center an error, and this one has a 0. Okay, hopefully you found that helpful to learn how to use your graphing calculator for graphing. We will explore all of these different graphs in depth as we go, but for now, today's lesson, we just want you to be able to use the calculator to find the graph and find the table. If you have any questions, please feel free to email me and I will get back to you as soon as possible. Have a great day, everybody.